Hello, ladies and gentlemen. It's Mr. Green again, and this is another in my recordings on Algebra 2 material. What we're looking at today is inequalities in two variables. Inequalities. Oh, those are those less than or equal to or greater than signs. I don't like that. Two variables. Oh no, Mr. Green, this is going to get really complicated. Nah, we're just going to draw some graphs of linear inequalities, and it's going to be really easy. And we're going to write some linear inequalities based upon a graph. So what we're going to look at to begin with is we've done linear equations. We know what a linear equation is. We've done them already. Here's a linear equation. Here's a linear inequality. These two are related to each other. I just replace this inequality symbol with an equal sign and I get a linear equation. That's one we know how to deal with. We can graph it and we can actually look at it and come up with the graph. What's the difference in this? This one will actually divide the plane in half, and you're going to get part of the plane shaded and part of it not shaded. What do you mean by shaded? Well, there's going to be more than one right answer to this one. Unlike on this one, there is a line that goes across the plane, and it just is that single line. This one is going to be a line plus a whole shaded side of the plane because that whole region is going to be considered to be a valid solution to the problem. Let's look at a couple, and I think you might see what I'm talking about. Here we've got two of them. We've got a boundary line. You can see right there. There's a line right there, even though it's a dash line. And over here, here's a line in this one, and it's a solid line. And what we're looking at is y equals 3/4 x minus 3. That's what that line is right here. And it's the same line over here, except it's a dashed line. And what have we done? If it is truly a less than sign, we make it a dash line because we can't really pick numbers that are on that line. If it's a less than or equal to, then we can pick numbers that are on that line and we make it a solid line. And then we have to decide which half of the plane we're going to shade. And you can see up here they've shaded this half green because this is the one that this side is where all the correct values are. How do I determine if I've got a correct value? I like to pick one point that is not necessarily on the line. And when I look at that one point and evaluate my inequality with that one point, if it's a true statement, then that's the side of the line I'm going to shade. Let me give you an example of what I'm talking about. You see this point right here, 0, 0? If I stick 0, 0 into this equation right now, I'm going to get 0 is greater than 3/4 times 0 minus 3. Well, anything times 0 is 0, so 0 is greater than -3. That's a true statement. That means everything that is on the side with 0, 0, which is the point I was using, would be shaded. If I got a false statement here, I would take everything that's not on the side with that 0, 0 and shade it. That's how you can go about figuring out which side of the line to shade, by sticking that one point in there. Now, why did I pick 0, 0 as the point to pick? Because I like multiplying by 0 and getting rid of that fraction. Okay? Could I have picked other points? Why, sure I could have picked other points. I could have picked 4, 4 out here. 4, 4 would work as well. If I stick 4, 4 into the equation, I would get 4 is greater than 3 over 4 times 4 minus 3. Wait a second, that's not 4, 4, that's 4 minus 4. So that's going to be a -4 over here. So -4 is equal to 3, and the 4's cancel out, and I get 3 minus 3, and that's 0. So I got -4 is greater than 0. Well, that's false. So I'd want to shade on the opposite side of where 4, -4 is. There's 4, -4 there. So I want to shade on the opposite side of that line from where that is. Can you see how I'm using the other side this time? And like I said, you could pick any point you wanted to pick, but I like picking 0, 0 because it really makes it easier to calculate a lot of times. But let's look at some problems and see if we can't figure out which side on our own without having them already done for us. If I'm looking at this equation right here, I notice that plus 1. That tells me that it goes through this point right there, point 0, 1. And then I also notice that I've got a slope of negative 2. That means it's going to go down 2 and over 1. Hey, it looks like I've got 2 points on there. I see that I've got a strictly less than sign. That means that my line is going to be a dashed line looking something like this. Okay? And probably more like this. Like that. Now the question is, which side of that line am I going to shade? I'm going to pick the point 0, 0, and I'm going to stick that in for the x and the y value. 0 less than negative 2 times 0 plus 1. Well, negative 2 times 0 is 0, so I'm going to get 0 is less than 1. That's true. So that means that I need to shade the side of the line that has, come on, work with me here, the side of the line that has 0, 0 on it. Well, that's this side over here. There's the 0, 0. So I'm going to shade this side of the line over here. And since it's a dashed line, it would be shaded. And you can see I can sit here in color for a while if I needed to. It brings out the second grader in you when you're working these problems, guys. So get your colors ready. And we did it. Ta-da! We shaded that side of the line. So let's go on and look at another problem, see what we can do. How would I graph x less than 1.5? Well, first of all, I'm going to find x equals to 1.5. Well, there's 1, there's 1.5. There's x 1.5. So it's less than or equal to 1.5. And since that is less than or equal to, I can draw a solid line that goes like this. Okay? And how did I know that it was going up and down? Well, because it's x. It's not y values. I don't have to worry about any y values here. It's just the x values. So I'm going to pick the point just like I did a while ago. I'm going to pick the point 0, 0. Is 0, which is the x value, 0 greater than or equal to 1.5? No. That means I need to shade the other side. The highlighter isn't necessarily staying on for me. I need to shade the other side of the line. I'd be shading this side over here. Once again, your second grader comes out in you here. You get it all shaded? Cool. So the question becomes, can you come up with values that actually work for this one? Sure, what if I picked the point 3, 6? I stick the 3 in for x, 3 greater than or equal to 1.5? And the answer is yes. So that would make it a valid, that would say that would be a valid solution to this particular problem. Let's look at a few more, see what we can come up with. How would you graph something like this? It's not in that easy form, Mr. Green. My response is, put it in that form. I'm going to add a negative 2x to both sides of this equation. Why did I add? Because when I add, I can use the commutative property. Okay? I'm going to get a minus 5y greater than negative 2x plus 10. Now I can use division, dividing by negative 5. And one of the tricks you can do here is divide both of them by negative 5. And you wind up with y greater than, negative divided by a negative is a positive. You're going to get 2 over 5 x plus negative 2. Hey, now that's in a format that we can graph. I'm going to come down here to negative 2 and make a point. There's one there. And my rise over my run is 2 over 5 So I went up 2 and I'm going to go over 5. There's 2, 3, 4, 5. There's another point right there. And I'm going to go down 2 and over 2. I'm sorry, 2, 3, 4, 5. There's another point there. And so if I just connect these with a little dashed line like this, and it should be a straight line and not necessarily have these bows in it, but that would be my line. I just graphed it. Oh, wait a second, we got to find out which side to shade, don't we? So I'm going to pick my trusty 0, 0 point, plug it in. I'm going to get 0 is greater than 0 minus 2, so 0 is greater than negative 2. That's true. So that means I'm going to shade the side that has the 0, 0 on it. That means I'm shading all this up here. Now, I'm not going to shade all of it. I'm just going to kind of sketch it there and say, okay, you get the idea. Everything will be shaded up there. Okay? So let's look at some more here. Now we get to write an equation based upon a graph that already exists. What I'm going to point out here is, well, there's the point where it's crossing the y-axis, so we know it's going to have y, and it's going to have a 4 over here, and it's going to be added on. We know it's got an x in here, because it's a linear equation, and look at my slope. It's down 1 and over 6. So that means it's going to be a negative 1 over 6. Now the only question is it pointing at the y or is it pointing at the x? I see that it's a solid line, so it's going to be less than or greater than or equal to, right? So let's see here. How do we decide whether it's less than? I know if I look at this point 0, 0 and put it in here, right? That's 0 here. And we know it's either going to be a less than or an equal to sign there. I'm just going to put a question mark there. Minus 1/6 times 0 plus 4. And I'm going to get 0, and I don't know what symbol to put in there, do I yet? Is equal to 0 plus 4. That means 0. I don't know what symbol yet. And 4. Well, 0 is less than 4. So I'm thinking that's what symbol I would have to put in there. It would be a less than 4. And I used that point 0, 0, which is here. And it's already in the shaded area. So I knew it had to be this symbol once I worked it out. Well, that works out pretty easy, doesn't it? Let's try another one, see what we got. Oh, wait a second. This one's really easy because it's y, and the line there is going through negative 3. Okay? And I can see that we've got everything that's bigger than that, so I know it's going to be greater than negative 3. Cool. Stick the point 0, 0, and the 0 is greater than negative 3. Yeah, that works. So it's up here. That's how you can do these. They're really simple to do. You just treat them like they're equalities and then decide which side of the line to graph. You have to remember dash line if it's not a inequality with an equal sign, but otherwise it's really easy to graph them once you get those linear equalities and you realize it's the same thing as what we were doing with linear equations. Okay? So, just letting you know, I still have lots of different courses. If you're going to send me a K-mail or send me an IM, make certain you tell me what course you're in so I can find your records a little bit easier. It helps me in solving these problems. I will talk to you later.